like priorities. And then like last night I was doing my IXLs and my worksheets that are due tomorrow. And then I woke up at like 1:30, like just something. And then I was like, you cannot do that. But yeah, if you want to see that,
is it like a shortcut to doing this?
You doing what? Yeah, based on the trend we did yesterday.
You said the trick or the trend?
the trend.
Trend.
Oh,
So no Destiny, no Joy, slash 326.
yeah. Just the up.
What's the boiling? Oh.
You got everybody else.
Boiling point is in the D.
Yeah.
Alright, so if we look at question 1, which has the highest boiling point? Where do we have to be for the highest boiling point? Alright, it should be a transition metal or a D block. So, according to what we did yesterday, the D block is greater than P, which is greater than group 2, which is greater than group 1 for density, boiling point, melting point, and hardness. Okay, all of those trends fit the one that I just wrote right there. All right, so since I asked for boiling point, D block would be the greatest. Now, what if you don't have a D block? Then you'd go to the P block. All right, so looking at where all these things are, this is in D, that's in group 1, group 17, group 17. This is group 13, which is your P block element, and that's in group 18.
So what if this is another one of those? The G2, the G1, P or D?
Given those are the trends I'm asking you to apply, why would I give you something that's not in the range?
I know, I'm just saying, but what if?
It's going to be there.
Okay.
Okay, so who has the greatest boiling point?
Nickel.
All right, now I put something beside number 2 because I forgot to use that terminology yesterday, so it was a reminder to make sure I pointed that out. When I ask for who's the most reactive metal, I can also say most metallic. All right, most metallic is another word that I can use instead of saying most reactive. Okay, those 2 words mean the same
I'm
thing.
gonna be freaking. Think about shiny stuff.
I'm just telling you it's the same word. Okay, most metallic and most reactive mean the same
I'm gonna
thing.
automatically put aluminum because it is silver and shiny.
All metals can be shined up.
So metallic are the ones in the middle? Or maybe I'm just tripping.
This wall.
Not necessarily. All right, what's the trend for reactivity?
The opposite.
It's the opposite. So this time, all right, we know the trend is group 1 is greater than group 2, which is greater than P, which is greater than D.
So it's
So we have how many in group 1 this time?
K and then A.
Okay, so we've narrowed it down to K and NA. They're both in group 1. So what do we learn about these are in the same group? As you go down, they become,
More reactive.
so who's more reactive?
Okay.
Potassium. Okay, so who's the most reactive non-metal?
Fluorine.
Okay, here we learned, or we should have, that it was group 17 is greater than group 16 and so forth and so on. So how many do I have in group 17? I have 2. I have fluorine and I have chlorine, right? Get rid of that little G symbol there. All right, so what happens is we go up the group. More reactive. So who's more reactive? Fluorine. All right, so who is the least reactive metal? It's the same trend as which one up there? The black or the green?
Black.
Black.
All right, the black went with density, boiling point, melting point, and hardness. And the green went with reactivity. So my question
I
is,
was looking at that.
who is the least reactive metal? So am I in the black or the green?
It's the green.
It's the green.
But I was looking at that. I was in the.
Gotcha.
It was still wrong.
So who is the least reactive?
Are you looking at the D?
The D block. So which metal is in the D block?
Nickel.
So nickel is the answer there.
So nickel is the answers?
To number 4. Now, did I say that you couldn't use something more than once?
No.
Yeah.
I didn't think we would.
We did all the homework.
Don't ever assume that. I pointed that out in the homework. Okay, that you couldn't repeat an answer. Don't ever assume that on this. Don't assume it on the test. Don't assume that on any quiz. Answers can be repeated on almost everything I give you, except that homework last night that I stressed it couldn't be repeated. Okay, otherwise answers can be repeated.
Right.
All right, which element is least reactive? Now, number 5, did I say metal or non-metal like I did in the other questions? No, so I'm asking either metal or non-metal. I'm not being specific. So who is least reactive? Neon. Okay, that would be the noble gas. That's neon.
Right.
All right, and which element has the highest density?
Nickel.
Nickel, D block. So nickel would be the answer there also.
Jeez, nickel counting.
Okay, questions? Any issues with the opening? No? Now, I won't share anything about the assignment in terms of answers right now.
Why are we learning this today? Right.
So how did you do that?
Because
Why?
again,
Don't make no sense.
Yep. if you graph correctly, then you have 60 points. And odds are good. Most of you are probably, unless you left it blank, in the 80s range. Now, I'm not going to say most of you, a lot of you sometimes don't even score in the 80s on a quiz, so stop complaining. Okay? This is all trends. The whole day today is trends.
Oh,
Okay? You're going to do 4 trends today. Sorry. We're going to do 4 more trends today, and then we're done with the periodic table. We'll practice tomorrow. We're going to do a lab grade, and then once we're done with that, we're going on to bonding. Tomorrow. It's a puzzle. I'm going to give you fake elements. You're going to have clues, and you're going to have to use your trends and your clues to figure out where these fake elements go based on the clues. Not now, tomorrow.
You didn't give me those the other day.
Okay, so atomic radius. Come on, we got an hour to get through 4 trends.
listen.
If we don't finish, you got to watch a video. That would be terrible to have to do that tonight, particularly for my Chick-fil-A people. All right. I know, that's my point. So let's get going. So, atomic radius. All right, so we learned in the last unit that we know we have a nucleus and we have some area of probability out here around the nucleus, right?
Still trends though?
Yes. So can we measure the distance between the nucleus and the outside of the atom?
No.
No. Okay? We don't know the definite end of an atom. Okay? Because we don't know the definite end of an atom, the way we do this, and this is going to look sort of bizarre, and I can't make it look any better. So I'm counting on some of y'all to actually pretend you're high school students and not middle school students.
You're high.
Oh my God.
Is we bond two identical atoms together. All right, and we measure the distance between 2 nuclei.
What? Did you restate that?
Thought I just said it pretty clearly.
You
All right, I will repeat it and I will explain. All right, so you bond 2 identical atoms together. All right, like 2 bromines or 2 chlorines. And then you measure the distance between the 2 nuclei. Because the nuclei are not going to change. Now, if we measure the distance between the 2 nuclei, is that going to be a radius?
No.
No,
That's just the
that's the diameter. Okay? So, if we measure diameter, you guys have all been in math class long enough to know we do what?
Couldn't tell you.
Pi r squared.
Divide by half. Divide by 2.
Yes. Okay, we measure diameter. So we take half the diameter, and that will equal the radius. Okay?
What if one is bigger than the other?
That's why I said we have to take two identical atoms.
Oh.
Okay? You can't take two different elements because then we can't take half because one will be bigger than the other. Okay? So that's the key. It has to be two identical atoms.
I'm so tired. And I can't even like this.
So tired.
I don't care about
Okay? It's a bond between two identical atoms. And you measure the distance between two nuclei, and then you take half the distance. Now, I can write an actual definition if you want.
No.
No.
Will that work?
For what?
Okay, for atomic radius.
Oh, yeah.
Okay. Now, we need to talk about the two trends. We need to talk about group and period.
This is.
Yeah.
Yeah, for just radius. You got to know what happens as you go across and as you go down.
See that one or how quick?
Mhm.
It increases and it
This is
decreases.
too many trends.
All right. So,
Wait, I'm not done.
Y'all right.
all right, let me go back. Y'all need to ride a little faster. Stop. Or I see some video in your future.
Who I'm watching? Are we gonna have
Who are you watching? The infamous Miss Wall.
I said, who's gonna watch it?
Nobody, probably, but unfortunately, you're going to need to know for tomorrow's puzzle.
Okay, I'm gonna throw out.
Fabulous.
Do we get partners with that?
Yep, one in two periodic tables. Now, if we do hydrogen, lithium, sodium, potassium, and rubidium.
That's the first group. Oh my God.
Hi, good.
No. That's what makes that. We done been there.
I'm doing them all in shorthand, and this is the only one I'm doing it for. You need to learn.
I wasn't here, and then I stayed for her to get help, and she did it.
Now,
Miss Wall,
what?
I'm not gonna be here Friday.
Don't care.
I mean, I know you don't care, but you should.
No, she
I'm
shouldn't.
gonna miss this class.
Anybody gonna miss
Where are you
your
gonna be now, Liz?
I'll miss you. Orlando Beach.
You're going to miss Lewis Structures and Adam Drummond.
You better
That and whatever we're doing Thursday.
Who you gonna be the buzz?
They're all for it.
I said I'm gonna beat the bugs. I was like, what? Okay, just get it.
Oh, the squall, the squall.
That's tough.
I really do need it. So I got the test, and I saw that they were
Don't pick it up
changing
next
to like
time.
LIs to HE, and I was so confused. I was like, what? And I went up there, she said, I'm just gonna say that's why I did that on my test.
Now, what's the highest energy level in hydrogen? 1. What's the highest energy level in lithium and sodium and potassium and rubidium? So what can you tell me is happening to the energy level in a group? Okay, so as you go down a group, the energy level increases. Therefore, the size of the atom or radius will increase.
Which one? Have you ever thought about writing and then saying what you wrote?
So what?
No, I like it when she does
No
this.
idea what you just said.
Increases.
All right, as you go down, radius increases. Now, Hydrogen has how many rings?
One.
Lithium has how many rings? So what's happening to its size?
Getting bigger.
Sodium has how many rings?
Three.
So as you go down the group, the number of rings is doing what? That's why radius is increasing. So as you go down, you're adding a ring with every period, so its radius is increasing. That's what I just wrote.
Thank you.
You're welcome. Okay? That was on your worksheet last night.
Yeah.
It was.
Thank you so much.
Oh, I didn't do it.
Google said the same thing.
I told you you could use internet resources.
Girl, you told me that you said that
See,
they
Google
were
helps with
wrong.
1 and 3, not so much 2.
Right. I know. So you should have a 95.
Google was like, good luck. See, we tried. I tried.
Oh, Caleb, did you find the sheet? The sheet. You told me you could find anything on Google. Did you find the sheet? Okay. Okay. I was just curious.
One.
You told me you could find anything on Google, so I was curious if you found it.
was such a black.
I did. I found the
I know. I would get it.
There's two of them that are wrong on that one.
I know, there's like multiple different.
I just compared the answers.
Sodium and lithium are the two that have backwards.
Yeah, I kept saying, okay, Google. What is it?
All right. So let's talk about a period. All right. So the one that causes issues is usually the period. All right.
Yeah. A lot of issues.
I know, right?
Not on the sheet, just when we do this on a test.
That's all you obviously do. Not
Well,
do
you
the
obviously
joke.
didn't do it.
Whatever.
Tell my one tampon. She didn't understand, so I helped me elaborate.
Now, I'm only writing the outer shell just because I'm limited on space to go across.
You're the one that said it causes a lot of issues.
The brackets would be HE. I wrote just the second period, but I left off the HE in brackets on all of them for the purposes of space. All right. Now, what can you tell me about the outer shell in all of these? Is my highest energy level or outer shell changing for any of these?
No.
No. Okay. So all of these are in
The same ring.
the same ring. Okay. So every one of these is in the second period or ring. Okay. So if they're all in the second period or ring, what do we know about the size? Is the size getting bigger?
No, it's not the same.
Okay. We know it can't be getting bigger. So if it's not getting bigger,
The electron.
all right, what is affecting its size from not allowing it to get bigger?
No, for electrons.
I heard it.
Protons.
Protons. Okay.
Speak up for what you believed in.
All right. So if we look at lithium, lithium has 3 protons. Carbon has 6. Oxygen has 8. And neon has 10. Okay.
How are carbon and oxygen, how do they have the same?
That should be a 4. Thank you.
Come on, Miss Walden.
Sorry, that's my fault. It's a 4. Yeah, I know. You're writing in pen.
We need you to wake up.
I know. It's my fault.
Okay.
Sorry, that's a 4. Now, so what do the protons do for those of you who did your homework?
What is protons?
The protons are increasing. That's good.
They tell you how many electrons there are.
They do.
Miss Wall.
What else do they do?
Something that I think you should get for your family because you have a family of 4, right?
This is important right now?
Yeah, it actually kind of is.
What?
There's 4 shirts, and one says proton, electron, neutron, moron. She likes it.
I can't even figure out who to put the moron on, but
You, Miss Law?
no, but I'm pretty sure he'd be insulted if I told him he had to wear it.
But hey, babe, can you put this on real quick?
Ah.
I saw that.
Homie.
I've seen all this information, but I can put it together.
Okay, protons pull the electrons closer to the nucleus, shrinking
Yeah, right. Okay, that's right. That's right.
the
Protons pull the what? Electrons.
size.
It's
Okay,
still two rings, but it's still smaller. Is that what you
so
said?
what happens as we go across the nucleus if we go from 3 to 6 to 8 to 10?
Shrinking? You mean shrinking?
Oh, yeah,
Skirking.
let me fix that. It looks a little stupid.
Shrinking.
Shrinking. All right, so if my protons are increasing, okay,
Well, I don't know if this year I felt like muted it.
that's all right. It doesn't seem to be affecting you. All right, so as the protons increase, the pull of the protons is greater. So size becomes smaller.
Wait, why does it pull?
I always describe it sort of like a magnet. Okay? The protons attract the electrons and it pulls them closer to the nucleus. Okay? So the more protons you have, the greater the pull to pull the electrons closer. It's called shielding. So if any of you use the word shielding on your paper, that would be a correct use of the word also. Okay? So as you go across, what's going to happen to size? So as you go across the period,
So wait, it's still two rings? It's just two smaller rings?
the second ring will get smaller. It will come closer as you go across. Size will decrease. All right, so as you go across the period, radius will do what? Radius will decrease.
So for our homework, did we have to say like the pool and stuff? Or could we just say that the protons increase?
You could have, and I will take that. I won't be very picky about your reasoning. As long as it's in the ballpark, I will give you credit.
Good, because we're doing
I can't. Miss Law, can you draw an example?
Yeah, I'm going to. I'm waiting on my slow riders to catch up. Faith will yell at me again if I turn.
Who are you adding?
Huh? All right, we caught up?
Miss Law, do you think if I die in my like restaurant bathroom, do I consider them?
Oh,
Like if I die from like exhaustion or something?
no. All right, so for my visual people. All right, as you go across, what do we say was going to happen?
It's gonna decrease.
It's going to decrease. All right, what do we say is going to happen as we go down? It's going to increase. All right, so you got a periodic table that's handy right in front of you?
Yeah.
Pull one out if you don't. Now, the F block, you don't set and draw up there. We're not going to use anything in the F block, so don't worry about it.
increases.
Yes, very good. All right, so tell me the biggest atom on the periodic table. Don't use the F block.
Copernicum. Yeah.
No.
What?
Wait, ours only goes to 112.
It's francium.
Francium is the right
How
answer.
y'all know this?
Yay, my boy France.
Weird. Friends.
How'd you find that?
Where's it? Yeah,
Because if you
All
get
right, in order to be the largest, you have to be the biggest going down. So you have to be in the bottom. Now, what happens is you go across.
you get smaller.
It gets smaller, which is why I said no to that answer, because as you go across, they get smaller. So it didn't matter that you stopped at 112. As you go across, they do what? they decrease. So 112 is going to be smaller than whoever's over here at Francie.
Yeah, but boy.
Okay? Now, who is the smallest
Radon.
element on the periodic table? Smallest.
Helium.
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 All right, so helium is the smallest. Okay? So, if I give us choices, we want to find largest or smallest. Largest, all right? You have a periodic table I can see. All right, pretend these are multiple choice questions and these are your 4 choices A, B, C, D.
Yeah, Joyce has bronchitis, so she's not coming.
Whoa.
Okay.
Oh, that's hot.
All right, out of those 3 questions, find the largest element in each.
11.
All right, I think I know.
Find the largest one in each.
There's one like him under the spot.
I'm so glad you did. All right, we got it.
Oh,
I got one.
all right. Maybe
Is it all right over there? All right. Oh my God, this is gonna smell today.
Witcher's back.
Witcher's officially.
All right, so we look at number 1. What can you tell me about those 4?
BA.
They're all in the same what? They're all in the same group.
Family.
So as you go down, they get larger. So who is the biggest?
BA.
Everybody agrees with BA? Good. All right. So what did you notice about number 2?
We couldn't find
They're
all
all
of
in
them.
the same spot.
They're all in the same period. So if they're all in the same period, who is the biggest? They get bigger as you go to the left. So who is the biggest to the left? NA. Everybody good with those 2?
Yeah.
All right. So the last one, they're all in a what?
Square.
They're all in a square. Okay. So I had what in this one? I had SE, I have TE, I have AS, and I have SB. So what do you know happens as you go down?
Gets bigger.
It gets bigger. So these 2 are out. And then what happens as you go across?
It gets smaller.
It gets smaller. So SB would be the biggest. Is everybody okay with how you do that?
Yeah.
All right.
I'm just gonna need more time because I struggle finding them.
Can we just stay on this?
No. All right. Everybody okay with the time of gradient?
I'll be looking for
All right.
them and
It's not hard as long as you know the trend. But if you come in tomorrow and you're like, I don't know where it gets bigger, then how do you apply it in the puzzle when it says element W is the largest radius in the group?
Okay,
And you've
don't
got to
word
put
it like
W.
that. That's what.
I'm just telling you, that's what the puzzle's gonna have. Okay?
This one has the largest radius. Who adds? Like, oh my God, this could confuse me tomorrow.
All
And you
right.
said we can't have our notes.
You cannot have your notes.
What is the point of me writing these right now?
So that you can go home and study tonight. So that tomorrow when you
I'm
come
gonna be
in,
serving you and your peers.
I'm not the one who scheduled the fundraiser. I
Yeah,
was planning on
but
making chicken at the house.
Alright, girl. And guess what? Go
We have
come
a
get extra
special
chicken
weather.
sauce. You get
Yes, I saw that come up on my phone. What does it say?
It says
Is it gonna snow?
It says mix of rain, snow, and a little sleet.
Oh my God, we gotta go.
Portions
Let's go.
of Piedmont, Western Sandhills, and then it's gonna mix of rain, snow, and sleet. In noon, participation becomes greatly heavy. A switch to mostly snow is possible, reducing the light dusting mainly on elevated objects and grassy surfaces. However, due to the warm ground, any accumulation will quickly melt, leaving the pavement just wet.
There you go. You're not getting out of school. It's just gonna leave the pavement wet. So,
Can we go home before fourth period? I didn't do my homework.
Please.
I don't think your odds and chances of that are very good based on, did you hear what Madison said after the however? The pavement is just going to be wet.
I thought this current on if you will be in at 12:30 today, please follow the schedule in your email.
That would be fabulous, but I don't think it's gonna happen.
Schedule it in your email.
All right, so ionic radii. You might remember the word ions from earlier in the semester. Okay? Ions, for those of you who forgot, are atoms with a charge.
Yikes.
All right, and we talked about two kinds.
Cat ion?
Yes?
And ion?
Very good.
Yay.
All right, now impress me even further. Tell me what a cation is.
Is that a positive and a negative or a negative and a negative?
Okay, we're on the right track. So which was the negative?
I'm gonna get
Which one was the positive?
cat.
Yes. All right, so the positive ion is the cation, and the negative ion is the anion.
She's excited we're learning.
Give her speeches.
Hi guys.
That was offensive.
She
to
talks
Miss Wall.
so much.
Who?
Miss Curry.
It's like caution.
I know she wasn't comparing me to Miss Curry because if she was, she just failed the semester.
Right, that's what I'm saying, Miss Wall.
You might as well
Big
go home.
ass
Bro.
zero. Hate Miss Curry as much as the student.
You might as well go home.
Right.
Girl, I wish I could do it. Let me tell you. I'd be so happy.
Now,
When a guy gets her license, it's bad. Yeah, I don't think we're ever gonna see her.
She follows me around, y'all.
No, first of all, she came to my place. Try again.
Yeah, she
Oh.
What?
so if we want to compare
Look, come here. I'm just sitting
the size of, let's say, O versus O negative 2. Now, I'm going to change this size-wise for, all right. Now, we refer to this as the parent atom and the ion. All right. Now, just to review again, what does negative 2 mean?
Negative 2. Positive. Oh, take away 2. Take away 2. You add 2. Yeah.
Negative 2 means you gain 2 electrons.
Yikes.
Wait, what?
All right. When it says negative 2, it means you gain 2 electrons.
Oh.
So, if we compare the ion to the parent atom, who would be larger? Why? That's right. It has more. Okay. This one is going to be larger. Think about it as gaining and losing weight. All right. If you gain electrons, it's like you gained pounds. You know, it might be easier for you to
I'm
keep
texting
up.
Joyce what we're doing right now.
Joyce can watch the video.
Joyce is stressed out.
Tell Joyce to watch the video, and that's what Miss Wall told her to do, and to
Okay.
stop bothering Annabelle so she can keep up in class.
So I'm talking about me. I don't understand what you just
Why
said.
don't you just
Okay? When you look at a regular atom versus its ion, and you want to figure out who's bigger and who's smaller, okay? If you gain electrons, it's like gaining weight. You're going to be bigger. If you lose electrons, it's like losing weight. You will be smaller. Okay? It's that simple.
So then why's that negative?
Because if you gain electrons, you gained weight, you're bigger.
So wait, what's that negative 2? Is it the opposite?
You gain.
Because you have more electrons. Remember, if we have, let's just say, I don't know, oxygen, since that's what we're talking about. All right, oxygen has 8 protons in the nucleus. All right, it has 8 electrons out here. All right. In order for it to get an octet, magic number of 8, all right, it has 8 electrons or 6 in its outer shell. In order to get to that magic number of 8, it has to gain 2, right? So if I gain 2 out here, all right, how many do I have now in terms of overall negative charges if I gain 2? I have negative 10, and I still have how many positives? So in math class, what do I have if I have 8 protons that are positive and I have negative 10 electrons? What charge do I get when I add that up? I have a negative 2. That's why when you gain electrons, you get a negative charge because you have more electrons than you have protons.
And if you lose electrons, you get positive.
You get a positive because you have more protons than you have electrons. So since you have more protons, you're positive. Does that make sense? Okay.
And I hope they do that, but.
All right. Is everybody okay with if you gain electrons, you're larger? If you lose electrons, you're negative? No. All right. What if I give you something like all right, and I ask who's larger or who's smaller. Change it up this time. I ask who's smaller. All right. Can you tell me this?
I'm not sure.
Gonna take it further.
Make it easier. No, because that's not what.
Because it's
It's
Oh,
making
because
it
it doesn't matter what the electrons they have.
All right. What makes this one different? What do you notice about all of them? They're all in the same group. Okay? So, all of these are in the same group. Now, if they're in the same group, what's the trend?
Bigger as it goes down.
That's right. As you go down the group, they get bigger. So does the oxidation number and the fact that they all lost 2 electrons matter? No. Okay? So you have Mg, you have Ca, you have Sr, you have Ba. So who's the smallest?
This has nothing to do with the ions.
Correct.
Those are all the same.
Right. This is the 2 ways that you will get the questions. Now, before somebody asks me, will I give you a plus and a minus or different oxidation numbers? The answer is no. Could I? Yes, and I'd teach that in an AP class. It's called an isoelectronic series. You will not have to deal with that in this course.
Well, tomorrow, are we gonna be able to ask you questions?
Huh?
Like during the puzzles, since we have our notes, can we at least ask you questions? Cause you know I'm gonna ask you anyway. I am too, until you answer.
I will answer very, very limited questions. Yes, I know. You've told me that before. All right. Ionization energy. 2 trends to go.
So if we just learned that with the whole ionic radius, and we're never gonna have.
And we're never going to have, because you have to be able to tell the difference between a parent ion and one that has the same oxidation ion. Okay? Now, ionization energy is the energy required to remove 1 electron from an atom. All right, it's the the energy required to remove 1 electron from an atom. Annabelle, you writing this down because I'm not waiting on you.
Sorry. That's really cool.
All right, it's the energy required to remove 1 electron from an atom.
Why would you need to remove it?
Because you do. Now, as long as you can remember that easy to remove the electron means we have what kind of energy?
Weak.
That's low energy. And hard to remove the electron. That's right. This trend is not hard to remember.
So wait, if you removed an electron, wouldn't it change the element?
No, it would just make it an ion. Okay, the only time you change the element is if you remove the protons. Okay, so wherever it's hard to remove the electrons, you're going to have high energy. And wherever it's easy to remove the electrons, you have low energy. All right, I waited long enough on everybody to catch up. Who said no? Okay. All right, so let's talk about the period trend. All right, so if we think about where our outer shell electrons are.
Never looks as good as that.
Remember, I've done this a long time. I'm good at it. All right, now I'll let you catch up. You don't have to make it pretty.
You do.
So what?
Never mind.
You just don't need to.
I'm talking to my teacher, not to home.
All right, so I'm just going to ask a question. Where is it easy to lose an electron? Where do they want to lose electrons from?
And the easiest, the lowest.
Okay, so
wait.
where in the outer shell do they want to lose their electrons? Which group says, please take them? I want to lose them.
The
I want
ones
to
that
give
are
them
easy to
away.
lose.
Oh, the
like
first one.
height,
The first one. Okay, so. All right, so here it's easy to lose electrons. All right, where do we not want to lose electrons? Noble gases. They have 8. They don't want to give up electrons. All right, so it's hard to lose electrons. All right, they already have 8. All right, so what's going to happen to our ionization energy then is we go from group 1 to group 18. Will it go up or will it go down? It will increase. Okay? If it's easy to lose here, this will be low ionization energy. Okay? Here, if it's hard to lose electrons, this will be high ionization energy. Any place you don't want to give away an electron, it takes a lot of energy to take one. Okay? Any place it's easy to lose an electron, really? That's fabulous. All right? Then it has low ionization energy. So, as you go across the table, ionization energy will increase because you get closer to 8 electrons, or what's the fancy word for 8 electrons? I heard it. Octet. Okay, so across, increase, ionization energy.
What's PT mean?
Here, octet.
Duh. See, it's snowing up there. Why are we
Little
here?
itty bitty tiny
But why are
stuff.
we here?
It's dangerous.
Because Poopy cannot make it through about anything. My car.
I know what it is.
It's like my walls.
I know, y'all taking these students down there. We're gonna stay at school.
Yeah.
Oh.
Somebody have to anyway.
They have to walk.
Say what?
Like, I have to walk up 2 streets to get to my house.
Well, at least you still have Memorial Day. It could be worse.
And we still have Good Friday.
Yeah, we still have Good Friday. We still have Memorial Day. It could be worse.
Hey, and does West in school the 12th too? Or is that just Central?
I don't know. They go 2 days with break though.
Central, they don't get out of school so much.
No, they get out before that, I think. I don't know. They might go.
Yeah.
If some goes, I'm sure let's go.
Yeah, because we were talking about how like I was getting excited talking to my friends like we should be getting this graduate next year and next year and we get out June 12th this year because of all the snow. Because they didn't do delays some days that we did.
Yeah, well, they're not in school as long as we are every day. They extend the schedule by 5 minutes, so they only make up like 1 day in going to school.
Yeah.
Whereas we make up like 3 days.
We go to school 30 minutes on, right?
We do a lot.
Right, we came to school.
All right.
We started leaving school later.
Yeah.
It's a whole.
All right. So for a group. All right. What's going to happen as we go down the group? What's going to happen to ionization energy?
What part are we on in our agenda?
We're still on.
Wait, what?
Can you guys be quiet?
What's going to happen as we go down a group?
Miss Walden, you put as you go across the periodic table, ion energy, does that say energy will increase? It's like a capital E.
Yeah, ionization energy. E's the abbreviation for energy. Ionization energy.
That equals energy.
All right, I'm only going to write 4 of them. All right. So what's happening as we go down the group? Why did I write those?
It increases.
It's on my desk. Use the white one at the top. What increases?
Energy level.
All right. So the energy levels.
Is this still ionization?
Still ionization energy. All right. So I wrote this up here to point out that energy levels increase. Okay. So why am I pointing that out? So what's happening to those outer shell electrons? Are they getting closer to the nucleus or further away? Okay. So the outer shell electrons are further from the nucleus. All right, so let's think about this in terms of a field trip. All right, so hydrogen has 1 electron, lithium has 3 electrons, sodium has 11, and potassium has 39. So let's say I take 1 child on a field trip. What are the odds I'm going to lose one kid?
Good.
No.
Bad.
Pretty low. I think I can keep up with 1 child. All right, what about 3?
And
It's a little high
it's a little bit.
Depends on how old they are.
True. I'm pretty good with 3 too. 11.
Yeah,
I'm good with like
39.
8 kids.
Let me take 39 people on a field trip.
Come on, Jimmy, go.
All right. Odds are not good that I'm going to keep up with 39 people by myself. Okay. Shocking. All right. Now, if I keep going down group 1, we get down to francium, we're at 87. Okay. It's very likely that I'm going to lose somebody out of 87 people, particularly when you think about the outer electron is on ring 7. Okay. So Here, I'm on the first ring, and I have one electron. Is it hard for the nucleus to hang on to one electron on the first ring? No. But you get down to rubidium. Nope, francium is one I used. Francium, we're on ring 1, 2, 3, 4, 5, 6, 7. One little electron out there on ring 7. How hard is it to pull off one electron on ring 7?
That shit gonna be easy.
It should be pretty easy compared to hydrogen up here with one ring and one electron. Okay? So as you go down and those electrons are further from the nucleus, it's much easier to remove. Okay? So as you go down a group, the ionization energy decreases because it is easier to remove an electron farther from the nucleus.
Jesus.
And I will draw a picture for my visual folks with the periodic table in a second. All right, so down, ionization energy, decrease. Yes, dear. Huh?
Why is it 39?
It was a 19. I used the mass.
So as you go down, ionization energy decreases.
Yes. Yeah, I'd use the mass. Can you what? Sure.
Why you be saying it like that? It's like you got a trick up your sleeve. Sure. It does.
King.
That's why you just said it a little quick.
Trying to imitate Joe Biden.
Man.
Can we stop here for today?
Nope. Got to do electronegativity. Then we're done. We got all the trends.
You call Miss Murray into a bestie though?
Huh?
You don't like Miss Murray into a bestie?
I didn't say I didn't like her, but she's not my bestie.
Well, the way your specialist person do something.
You know, sometimes I have a hard time controlling those. It's like I have one of those diseases where it just sort of does things.
That's why they don't put me on front counter. Because I'm like, you said what? Yeah, I can't hear you.
All right, so what did we say happened for ionization energy as you go across?
It should increase.
It did what? I heard it.
Increase.
It increased. All right, what happened as you go down?
Decrease.
It decreases.
It's the opposite of the.
There's where I was going next. It's what?
It's the opposite.
All right, it's the opposite of atomic radius. Now, I don't care how you learn the trend. I'll be the first to tell you I don't keep this one in my head. Okay? I just don't keep it in my head. I keep atomic radius in my head.
No,
And I know this one is the what?
The opposite.
It's the opposite. Okay? You learn how you guys should know at this point your learning style. You should know how you learn best. All right? I'm a great auditory learner. I can listen in a history class and absorb. But in some classes, I'm a visual learner. So if you look at my answer keys, I have most stuff worked out. In a math class, I'm a visual learner. I cannot process auditorily. I have to see it. So if you look at my answer keys have arrows drawn like this all over.
Thinking about
Okay? So when I write ionization energy, I've got this written down because I know that's my learning style. Okay? But I know this one frontwards and backwards. This is atomic radius because I committed that one to memory years ago. So I know ionization energy is the opposite. So all I have to do is ionization energies increase, decrease. That's the method that works for me. You find a method that works for you to learn the trends. Okay? I know this is atomic radius. Now I know that's ionization energy. I don't care how you do it. You have to find a way that works for you. Okay? So if this is the opposite, and I knew what? You want me to put it back? Okay. Atomic radius, decrease, increase. So ionization energy is the opposite. So this will be increase, decrease. All right, but you have to find a way that works for y'all. That's the way that works for me. All right, if visual stuff doesn't work for you, don't do that. Find something that works for you. Okay? Go right ahead. All right, so a minute ago, we said francium was the biggest atom. So now what would francium be for ionization energy? It'd be the smallest ionization energy. Okay, so francium would be the smallest here. And that would make helium the what? It would make it the largest for the ionization energy. Okay? Because they're opposites of each other. Does that make sense?
Yes.
Okay.
Are we done?
Got to do electronegativity.
Oh my god.
And then we're going to mix it.
Oh no.
Yes.
Stop. I can't remember. So what?
Are we looking at worksheet now?
Yeah, we're going to do a worksheet. If we have time, we're going to do flickers.
Clipboards. Flickers. Oh no. I said clipboards.
All right. We'll just have to see if we have time for that.
No.
Might have to move flickers to tomorrow. All right. Electronegativity is the last one. And it's the one we'll use in bonding. Okay. Electronegativity is huge in bonding. Now, electronegativity is a measure of an atom's ability to attract electrons to itself in a bond. Okay? A measure of an atom's ability to attract electrons to itself during a bond.
No, but like it's snowing so
Like mega snowing.
Where's Rinkin?
It is
We should
snowing.
go home. Miss Wall,
It is
where's
not
Rinkin?
mega.
My heart doesn't do
Where's
well.
who?
We get hydroplane and die. My heart's gonna go. My heart's gonna go pee on
Yeah,
the
go
road.
home, so.
My heart isn't awake.
Oh, and actually, oh my god, I see it now. You just have to have.
Oh,
Okay, now that's a little more stuff.
Wait, you say it's snowing in Wicked?
I'll let you know.
Oh, that's my.
Really? We
It's
should
beyond me.
send you a picture. Sure, okay.
Let me collect that.
That's why I think we're going home.
I don't think you're
Maybe not. I'm about to go off here and get the sun.
I just say that. What about me?
I did not get salt.
I'm just throwing metal.
I'm gonna get
You're gonna get blown
She
away.
does not. I would use you for my heat example in physical science. I probably used you back when we did it. But you ain't got enough meat on your bones.
This is attraction. Electrons.
See, how do you feel about your
I say auto take the hose and spread all over the snow.
outside?
Yes, the way it gets cold.
You know what I feel about my kids being outside the snow? My kids are snow.
It's like them taking water for.
Yeah, but and
Yes, go toward up with
Yeah.
water where she can.
My kids
I
are
Yes.
I do. No, we should be
A few
going.
years ago, this one might, but right now.
I
it's-
see it before.
Alright, electronegativity.
The wind's blowing, it's snowing, I want to
So I drew HCl on the board, right?
I guess.
And I drew two dots. Those dots are going to represent electrons. So we're going to learn about this later in the week. I want you to think of it as a tug of war. Okay? H and Cl. All right, and I'm going to pick on two people to do this. So I'm going to pick on Noah and Nylasia. All right, Noah and Nylasia are in a tug of war. All right? So,
Who's gonna win? I wonder who's gonna win.
I know.
Get a rope.
Now, hydrogen has how many electrons in its outer shell?
One.
All right, it's in group 1, so it has 1.
7.
All right, chlorine's in group 17, so it has.
7.
All right, so based on what we've learned, what do we know hydrogen wants to do?
Oh, lose one.
Wants to lose 1 electron. All right, what does chlorine want to do? Wants to gain 1. So based on what we know, hydrogen wants to do what with its electrons? Wants to lose it. So hydrogen wants to push the electron that way. And chlorine wants to do what? Wants to gain it. Okay? So based on that, we know that who theoretically should be stronger in this tug of war with the electrons? Chlorine. Okay? So the electronegativity is greater for chlorine. Okay? And the abbreviation we use for that is En. So the En for chlorine is larger. Okay? So chlorine would be Noah. Hydrogen would be Nylasia. I know. We probably all predicted that Nylasia was going to win. And I mean no disrespect to Nylasia, but she would not have been my first choice for the tug of war team. Okay?
But like, if she was on the track.
Now, she might have been my first choice for track. She would not have been my first choice for tug of war. She looks fabulous. All right.
It was her birthday last week.
It was.
Oh yeah.
Happy birthday,
Happy
Victory.
birthday, Victory. Y'all look at Victory.
She's one of those people who takes her birthday off so come to school. And
No,
she wouldn't feel well.
She was
Right.
there spending money. She said, "Get all your broke hoes."
All right. Does everybody have what they need? Now, let's talk about each trend.
feel the coldness coming through. Annabelle.
And stop standing at the door, Dingus.
Can I open the door?
No. All right. All right.
Spring break is literally next week, baby.
It's not next week. So if we look at the trend,
She said the whole quad of their college is completely.
Miss Hinson said she agrees that we should be leaving right now.
Miss Hinson texted you personally and said we should leave.
I said, okay, it's a blizzard outside. Why are we leaving? She said, I agree. I wish.
That would be fabulous, but we'll probably still
I'm
stop.
gonna say, let's leave.
Yeah.
All right. So if we look at the periodic table, the trend is the same as ionization energy with one little exception. So what happens as we go across? They increase. Okay? As we go down, it decreases. Now, here's the catch. Okay? The catch is the noble gases. Okay? Helium. I know, they always do. Helium, neon, and argon. These three right here.
Those are the ones that won't react.
There's the ones that won't react. They have no electronegativities. Okay? So, where does the electronegativity stop then? All right? It stops at fluorine. All right? Fluorine is the highest.
What do you mean it stops it?
So it goes to fluorine and it stops. Fluorine is a 4.0. Okay? So it increases as you go across to fluorine. And it increases as you go up to fluorine. All right? But it stops at the noble gases. Now, when we do ionization energy, do we include the noble gases?
No. Yes.
Yes. Ionization energy uses the noble gases.
Yes.
So you have to remember that ionization uses the noble gases. Electronegativity does not use the noble gases, and it stops at that column, the halogens, with fluorine.
So what about
What?
krypton?
I cannot control the weather.
You should check your email.
What about
I've not gotten a beep on my phone. Nothing's come in, Annabelle.
krypton?
I promise. I'm not ignoring you.
When y'all are attending my.
What about the ones under our
Say
table?
the end.
So.
The ones under our roof, technically, yes. And we'll learn more about those in the next year.
I would say Chick-fil-A's email.
You think they're going to close Chick-fil-A?
Hold up, we feel like
They did last time. They closed early because of the snow like this.
Yeah, we did. We closed like 3
Would you repeat what the weather said for Annabelle in there?
No.
It changed. It said it's gonna stay and like be here so we can leave.
Right.
I want to see if Chick-fil-A said due to the weather.
Do they take the milk?
Exactly. It's still gonna be here.
You gotta tell me twice. That's who won't be there.
I'm your favorite student.
Are you having crack fun?
Yes.
Why did you say crack? Why did she have crack fun?
That's still a lot of
It's dumb, but she's putting it in my roll. Alright, the worksheet that Cecilia's given you is review of what we've just done.
Right.
Now, it has 10 questions, I think. Yeah, 10. Alright, they're mixed up. Alright, with the trends. You should be able to use your periodic table and figure out which one is the right answer. It looks like roughly half the next test we're taking. It's also similar to the quiz we will do on Wednesday, Thursday.
Can we freaking leave?
One lower.
No!
Everyone just needs to let them all walk out.
That's why they're right here.
Oh, they got to take a look. I'm not here.
Yeah.
I didn't want to draw.
Annabelle, there's an email.
Are you serious?
No. As you go towards fluorine, it stops. Increases
It only decreases on this side?
No, it decreases as you go down anywhere. So if you start at fluorine and went down, it would decrease.
Oh, there you go.
Yeah, I just wrote it off. Yeah. You have a question? No. Find the answer. We're not going home, so suck it up and find my answer.
We wouldn't even go.
Wow.
We don't want to day off work. I don't work today. Where do you work?
Somebody asked you, Sessie?
Where?
Your girl works 2 to close Saturday.
I'm going to try a bit, but it's fine. I only work in the morning.
I hate people who work barely ever and then they complain.
I don't complain.
No, I work more than like just Saturday. But
I'm talking about people at our job, like, they're working day, they're working day, and then they don't got to go. You don't shut up.
This is your window.
Find me some answers, people. Or we will not review before the puzzle tomorrow, and we'll have our quiz tomorrow. If I'm tired of asking. I don't mind threatening you.
The snow is already threatening.
We're not about to leave.
Yes, we are.
That would be fabulous. I'm just a realist. We're not going anywhere.
She's ready to
Let's
If it was like 20 something would be good.
Which one? Number 3? Yeah, what about it?
It's asking which one.
I hope it does.
Use everything.
I'm
Yeah.
gonna ask you to look at this one. Can you tell me if it's the right answer?
Which one? Which one?
BA is a non, is BA a non-metal?
No.
It's a metal, right?
BA is a metal,
Okay, I thought.
so it cannot be a non-metal answer.
For real?
Well, where would we look for when it says which metal is the most reactive?
It's the trend that goes group 1, group 2. Yeah.
Yeah, okay. Here's the wall. Can I use the bathroom? I do. Can I take this one?
Yeah, that's fine.
Bless you.
It's hard to react.
Hey, do your work.
I don't know which
I'm sorry, Holly.
Because it's minus 1. Is there an email?
No. Putting questions at play. There's no email. The only thing I had was from Carolina Biological.
What's that?
It's the science company trying to get me to buy stuff. We have the money, we're broke. So I did.
Why are like all the teachers like not like personally like but like whenever they have like money they have to spend on their class part? I mean, you.
Those $900,000 in debt.
How are we open? Oh my God! How?
Because we lost 100 and some students to the charter school and other schools, and they didn't budget for that, so we had to pay that money back to the county, the state.
Well, with the,
How are we open
from here with the charter
school?
the charter school?
Elementary schools, they're only K-3 this year.
Yeah, they're building every summer until they.
The charter school is
But we still have to pay them back even though we're getting out of school.
That's why attendance in the first 10 days of school is so important. That's where we get our state allotment from.
Yeah, the charter school was like struggling. They keep coming in for like 10 nights. Like y'all know, how are we still open?
Well, we have all of y'all, so we got money for that. We just didn't do a good job estimating.
I did an April Fool's joke and I posted on Instagram that I was moving to Central and so many people believed it and it was hilarious.
What they say?
They were like,
I don't know, like, thank God it's not one.
they were like, oh my God, are you serious? I was like, yeah. And they're like, what classes are you taking next year? Hopefully we'll be in some together. And then like some girls I've never met, they're like, this better not be an April Fool's or I'm gonna cry. And I was like, listen, I've never talked to you.
Don't know you.
Yeah. But like they all believed it. And some of the friends I'm really close to really believed it. But look how real I made it. Look, cause I was in a Central shirt for the thing I put. Yeah, I had to say happy birthday to Charlie. I was in a Central shirt. And like when people find out like why, I'd be like, my sister's graduating and moving to the lake this summer. You try to say it's never this. And then I put
I'm gonna say it's my birthday. It's like you got free dessert. Which I did for dessert.
Like those cadenas.
Oh.
to like whatever.
Oh, that's cool.
Yeah.
So,
I did the back yesterday.
I read the back.
I had a clear and the back. And the video.
No, you're on the same level. You're on the same level. That's the biggest.
It's my first year.
Sorry.
What do you give?
The total radius is down, increase is
What?
and across.
Raquel, you done? Raquel, you done?
What did?
Madison, you done?
I have one better.
What's up? Daisy, you done? That translates to no.
Almost freezing.
But I do have a real question.
What's the real question?
So like, are we doing all what we learned today or like also learning it?
If there are any questions that say melting point, boiling point, freezing point, reactivity, and includes both.
Okay, cool.
Miss Laura, I'm sorry.
We're gonna go over it, but we're gonna see how far back.
Which one we talking about?
All of them.
Oh, we're gonna go over the answer.
Another consideration. It's just
Okay?
Yeah.
And then that's all I got.
Done.
Okay.
I'm really sad. Oh, wait.
Which element was one?
Group 2 of non-metal.
Reoxidation.
Kind of talking this wall. So, it's group 2 of non-metal.
You're not being correct.
It is.
No,
You still have these.
Linda, there's 3 of them. I was gonna say, point to where the non-metals are on the periodic table. Linda, show her where the non-metals are on the periodic table. Point to them, board.
I don't care about any name that's simple. Match. That's the one I have.
In the middle.
That's the one.
We basically came to eat yesterday.
I don't know.
Because they had
I'm not gonna
breakfast.
cry.
Food, curly hair, dude. White.
Wow, Martin. Martin? The lowest one.
Who, where do you work again? Because of? No. Like, La Harlem Grill? Oh.
Oh, he probably did go
Yeah.
Does that help?
Hey, this is-
Right.
Like Winston Road essentially. You would think that because of your good look, yeah, more people would come to Smile or we're getting good looks.
What is that?
The earliest one finds something on this puppy is just really small. Yeah.
When are you moving location?
Depends on how much money they're gonna give us.
So it's
I won't be here, so it won't matter. Yeah, like our fourth good. It's
Well, we have the Band-Aid.
the only time we have really good. The last Sunday was kind of bad. Normally we make like she made like last Sunday she made.
They always make some funny meme.
Oh,
Like, those are just make the face bigger and having fun.
All right, if we had enough time, should we go over it?
Did you know that Chinese food, if we make it work, are going to help?
And I do people that Smile is a Christian and stuff.
That's what you think. Not just the church gates. Just across the
Who has kids?
Me. Yes.
Now?
You're good.
Oh, wow.
I don't know what's going on.
I'm pretty sure
This is why I'm like,
I'm gonna sit here.
All right, let's run through the answers. Question 1, most reactive. Group 2, P block, that was not a metal. Okay, so sulfur's out because it's not a metal. P block in group 2, who's more reactive, group 2 or P block? Group 2, they're both in group 2. What happens is you go down, you get more reactive, so it has to be SR. Everybody okay with that?
Yeah.
All right, number 2, which non-metal is least reactive? Ba is out because it's a metal. All right, they're all in group 17. So you have chlorine at the top, then Br, and then I, because they're all in group 17. As you go down, they get less reactive because we learned the trend, they get more reactive as you go up. So who is least reactive? Iodine. All right, ionization energy, we learned as you go across, they increase. As you go down, they decrease. All right, so these are all in a nice even period. So you have Na, you have Mg, you have Cl, and you have Ar. So who will be the highest?
CL.
Ar. Right? Electronegativity is the one that leaves it out, not ionization energy. So Ar is counted because we're doing ionization energy. Okay? Now, I have ions. This means you gain 3. This means you lost 5. So who will be the smallest? B. All right, number 5. Which element has the smallest radius? We know if we go across, it decreases. If we go down, it increases. We have K, and we have Ca, and then we have Rb and Sr. So if we go down, they get bigger. So those two are out. As we go across, they will decrease. So who is the smallest? Ca. All right, highest melting point goes to face question. Did I include anything from yesterday? Yes. D block is greater than P, which is greater than group 2, which is greater than group 1. So do I have anybody in the D block? Fe. So Fe is the answer. All right, 4 outer shell electrons. What group has 4 outer shell electrons? All right, group 14. So group 14, group 13, group 16, and group 15. Whoops.
I just realized those match the numbers at the end.
Yep.
That's how I remember.
At the end of the group.
Because you subtract out the D block, the transition elements. All right. +3 ion is the same thing as a +3 oxidation number. So, who has a +3 oxidation number? Al. All right. Atomic radius again. As you go across, it decreases. As you go down, it increases. So, who has the greatest when you put those on here? You have K, you have Mn in the transition elements, Ge and Kr. So, who's going to be farther across? Potassium. And smallest ionization energy? Yes. All right. As you go across, it increases. As you go down, it decreases. You have Cs, and then Na, and then Cl, and then what else do I have? Si. So Si and Cl are here, and then Na and Cs are there. So they're in the same group. So as you go down, they get smaller. So Cs will be the smallest. Questions? Now, I have one that I can give you for homework if you'd like to practice. But your biggest homework is to do what? To study. Now, I don't know, I didn't look.
Yes.
Tomorrow, you and a
Oh
partner get 1 periodic table each. So each group gets 2 periodic tables. You may choose one with numbers, like the orange one, which I would strongly recommend. And then I would choose either the one that has the SPDF blocks.
Yeah, getting
Or the
drunk,
one that has
yeah.
like solids, liquids, gases, that kind of thing on it. Depending on whichever one you and your partner decide, you know the least. If you know the SPDF numbers pretty well, in the SPDF,
Oh, you missed out.
And this one,
y'all keep giving me tables back over there. Giving her the worksheets back.
well,
I said issue number.
you should let me stay in
Now
here.
I got a table.
Why?
I don't wanna go there.
Go where?
Freaking fashion, Marty.
Well, you gotta go.
Oh,
Alright?
Go to Kitchen Bread.
So think about what you do and don't know tonight, because you only get one periodic table each. The questions I answer will be very limited.
Oh, hush.
Okay?
I'm literally quiet.
Like, not these, but like where you did like this.
Dude, it keeps getting worse and worse. Let's not go outside.
It's no.
It's snowing, you guys.